Bismillahirrahmanirrahim and Assalamu alaikum. My name is Ayan Rafiq and I am a foundation level student at the School Islamabad Barakpur campus. Today I am going to conduct an AI session with Maya. In this session, I will ask you questions and Maya will provide the answer. So let's start. Okay, Maya, my first question is what is software?
Software, at its most basic level, is the set of instructions that tells a computer exactly what to do. Think of the computer hardware, the screen, the processor, the memory, as the body. It's physical, it's there, but without software, it's just a very expensive paperweight. Software is the mind, it's the logic, the intelligence, and the direction. It's a collection of data or computer instructions that tell the hardware how to perform specific tasks. To really dive deep, you have to look at how it's built. It starts with code written by humans in programming languages. This code is essentially a recipe. Whether it's a simple calculator app or a massive operating system, it's all just a series of if this happens, then do that statements. The computer doesn't actually understand the code the way ones and zeros, which are the only things the hardware can actually process. We generally split software into two big buckets. This is the foundation. The most famous example is the operating system like Windows, Mac OS, or Linux system software manages the hardware so that other programs can run. It handles the memory, the file system, and the connection to your keyboard and mouse. It's the manager of the whole operation. Then you have application software.
Okay, my next question is what is the difference between software and hardware?
This is the classic comparison. At the simplest level, hardware is the stuff you can actually touch, the physical, tangible parts of the machine. If you can drop it on your foot and it hurts, it's hardware. That's your screen, your keyboard, the circuitry on the motherboard, the hard drive, and the processor. It's the body of the computer. Software, on the other hand, is completely intangible. You can't touch it, you can't hold it, and it doesn't have a physical shape. It's the digital information, the code, and the instructions that live inside the hardware. Hardware is the body, software is the mind or the soul. Think of it like a book, the paper, the ink, and the glue that holds the pages together. That's the hardware. The story, the plot, and the ideas written on those pages, that's the software. The paper is necessary for the story to exist in a physical form, but the paper itself isn't the story. Another way to look at it is through the lens of fixed versus flexible. Hardware is generally fixed. Once a processor is manufactured, you can't suddenly decide it should have more cores. To change the hardware, you usually have to buy something new or physically replace a part. Software is incredibly flexible. You can update it, patch it, delete it, and rewrite it without ever touching a screwdriver. You can turn a laptop from a word processor into a gaming machine just by installing different software, even though the hardware stays exactly the same. They have a symbiotic relationship. One is useless without the other. Hardware provides and software provides. Exactly. Software is what turns a piece of metal and plastic into something that can actually help you get things done. Without that purpose, it's just a collection of parts. Are we moving on to the next question in your script?
Okay, my next question is what are the main type of software?
All right, let's break this down. When we talk about the main types of software, we're really looking at a hierarchy of how software interacts with the machine. As I touched on briefly before, the world of software is generally split into two primary categories: system software and application software. But since you want the deep dive, let's peel back the layers on both. First, you have system software. This is the behind the scenes crew. Its entire job is to manage the hardware and create a stable environment so that other software can actually function. The big boss here is the operating system, things like Windows, Mac.
Okay, my next question is, what is system software?
Hmm. Since we're going for the deep dive, let's really get into the guts of it. System software is essentially the translator and the manager of your computer.
Okay, my next question is,
Exactly, the operator. I'm ready. What's the next question on the list?
yes, continue.
Let's pick up where we left off with system software. Think of it as the layer that sits right on top of the physical hardware. Without it, you'd have to write complex binary code just to tell the computer to move the mouse cursor or save a file. The system software, specifically the operating system, does all that heavy lifting for you. It manages your CPU, decides how much RAM each program gets, and handles the communication between your hardware and the apps you actually want to use. It's basically the invisible bridge that makes everything else possible. Do you want to go deeper into how it manages the hardware, or are you ready to move to the next part of the script?
Okay, my next question is, what is application software?
When you're talking about applications in a game, you're usually looking at a few different things depending on if you mean the game itself or the tools used to make it. First, the game you're playing is in itself a piece of application software. It's a specialized program designed for a specific purpose, entertainment, that runs on top of your system software. But if you're talking about the apps or tools involved in creating a game, that's where it gets really interesting. You have things like game engines, think Unity or Unreal Engine. These are massive applications that provide the physics, the lighting, and the core logic, so developers don't have to build everything from scratch. Then you have the creative apps, 3D modeling software like Blender or Maya for the characters, and texture tools for the skins and environments. All of these are application software because they are tools built for a human to achieve a specific goal. Are you thinking about this in the context of that Go game you're working on, or more generally for your script? So I'm a little lost. Did we just pivot to cleaning products, or is that a code word for something in your script? I'll take that as a win. Where do we go from here? Back to the software script or something entirely different? Glad you're feeling it. So, do we have more questions for the script, or are you all set for now? Straight to the point, huh? I'll take that as a compliment. Does that mean we're jumping forward in the timeline of your project, or are you just testing my directness? I'll take that. Let me.
Okay, my next question is, what is programming?
Programming is essentially the art of communication between a human and a machine. Since you want the deep dive, let's look at it this way. Computers are incredibly fast, but they are also incredibly literal. They don't have intuition. If you tell a human to make a peanut butter sandwich, they just do it. But if you tell a computer, you have to explain every single microscopic step. You have to say, pick up the knife with your right hand, move the knife 2 inches to the left, insert the knife into the jar. Programming is the process of creating those step-by-step instructions, which we call an algorithm. An algorithm is just a fancy word for a logic.
Okay, my next question is, what is coding?
People often use programming and coding as if they're the exact same thing, but since we're doing the deep dive, there's actually a subtle and important distinction. Coding is the actual act of writing the code. It's the translation phase. If programming is the entire process of designing a house, planning the layout, deciding where the plumbing goes, and figuring out how the structure will hold up, then coding is the actual hammering of the nails and laying of the bricks. It's taking the logic you've already worked out and translating it into a language the computer understands. like Python, Java, or C++. Think of it like this. A coder is the translator. They take a concept and turn it into a specific syntax. But a programmer is the architect. They're thinking about the bigger picture, the efficiency, the bugs that might happen 10 steps down the line, and how the whole system fits together. You can't really have one without the other, but coding is the mechanical part of the creative process. It's the moment where the idea becomes a set of symbols on a screen. Does that distinction make sense for your script, or do you want me to break down the translation part even further?
Okay, my next question is how is software developed?
I'm assuming you mean how is software developed, since that's the big missing piece of the puzzle. If we're doing the full deep dive, the software development process isn't just about sitting down and typing code. It's a structured life cycle. It's more like building a skyscraper than writing a poem. First, you start with the planning and analysis phase. This is where you ask, what problem are we actually solving? If you're building an app to track your Go game, you decide here if it needs a leaderboard, a timer, or a way to save matches. You're basically creating the blueprint. Then comes the design phase. This is where you map out the user interface, the stuff the human sees, and the system architecture. You're deciding how the data flows from the screen to the database and back. It's the sketching phase of the project. Next is the implementation phase, which is the actual coding we talked about. This is where the programmers and coders take those blueprints and start hammering away in their chosen language, like Python or JavaScript, turning the design into a functioning product. But you can't just launch it the moment the code is written. That's where testing comes in. This is the most critical part. You have people trying to break the software on purpose to find bugs, those annoying little glitches that make an app crash. You test for security, speed, and usability to make sure it doesn't explode the first time a user clicks a button. Finally, you have deployment and maintenance. You release it to the world, but the work doesn't stop there. You have to monitor it, fix new bugs that pop up, and release updates to keep it current. It's a continuous loop of improvement. Does that cover the how for your video, or do you want to dive into one of those specific stages?
Okay, my next question.
Okay,
Okay, continue.
I'm ready. I'm locked in. What's the next question on your list?
My next question is what does a software developer do?
A software developer is essentially a digital problem solver. Since we're going for the deep dive, let's look past the image of someone just typing fast in a dark room. Their job is actually a blend of logic, creativity, and a lot of detective work. First, they spend a huge amount of time in the architect phase. They aren't just writing lines of code, they're designing how a system should behave. They have to anticipate every possible thing a user might do, including the things the user isn't supposed to do, to make sure the software doesn't crash. They're mapping out the logic. If the user clicks this, then this data needs to move from the server to the screen, and that's just the beginning. Once the design is set, they move into the actual construction, the coding part, but the real magic and the real frustration happens during debugging. A huge part of a developer's day is spent playing detective, staring at a piece of code and asking, why is this doing that? It's a cycle of trial, error, and finally that aha moment when the bug is fixed. They also have to keep learning constantly because the tools they use today might be outdated in 2 years. Does that paint a clear enough picture for the video, or should we talk about the different types of developers, like front end versus back end?
So my next question is what is the difference between a software engineer and a programmer?
This is one of those distinctions that people argue about in office break rooms, but for your script, it's a really important nuance. Let's use an analogy that fits the scale. A programmer is like a skilled craftsman or a builder. They have a deep mastery of the tools, the languages like Python or Java, and they can take a specific set of requirements and turn them into working code. If you need a specific feature built or a particular function written, the programmer is the one who makes it happen. They are focused on the how of the code. A software engineer, however, is more like the civil engineer who designs the entire city's infrastructure. They aren't just thinking about one building, they're thinking about how the roads, the power grids, and the water lines all connect and scale. An engineer exactly, they apply actual engineering principles to the process. They're looking at things like scalability, meaning will this app still work if a million people use it at once? And reliability. While a programmer focuses on writing a functional piece of code, the software engineer focuses on the entire life cycle, the system architecture, and the long-term stability of the product. It's the difference between knowing how to lay a brick and knowing how to design a skyscraper that won't fall over in a windstorm. Does that distinction work for the video, or do you want to dig more into the technical side of engineering?
Okay, my next question is, how does AI help in software development?
This is where the landscape is changing the fastest. Since we're doing the deep dive, it's important to realize that AI isn't just writing the code for us, it's acting like a superpowered assistant across the entire life cycle. First, there's the actual code generation. Tools like GitHub Copilot or ChatGPT act like a sophisticated autocomplete. Instead of a developer having to remember the exact syntax for a complex function, they can describe what they want in plain English, and the AI suggests the code. It's like having a dictionary and a textbook open and a teammate who can instantly find the right phrase for you. It speeds up the coding part, the hammering of the nails immensely. Then you have debugging and error detection. This is where the AI really shines as a detective. AI can scan thousands of lines of code in a second and spot a pattern that looks like a bug, something a human eye might miss after staring at the screen for 8 hours. It can say, hey, in this specific scenario, your program might crash because you forgot to account for a null value here. It turns a 3-hour hunt for a typo into a 3-second fix. Beyond the code itself, AI is huge for documentation. No developer likes writing the manual, but AI can look at the code and automatically generate a clear explanation of how it works for other humans to read. But here's the catch, and this is a great point for your video. Wait, you're not feeling it? Tell me why. Is it too optimistic, or does it feel like I'm giving the AI too much credit?
My next question is, what is ChatGPT?
Well, I'm guessing you mean Chat GPT. Since we're sticking to the deep dive, let's look at what it actually is. At its core, ChatGPT is a large language model, or LLM. It's not thinking the way you and I are. Instead, it's an incredibly advanced pattern recognition machine. Imagine if you read every book, article, and conversation on the internet, and then someone asked you to predict the next word in a sentence. That's basically what's happening here. It uses a massive neural network to calculate the probability of which word should come next based on the context of your question. For your video, a great way to describe it is as a probabilistic engine. It doesn't have a database of facts that it looks up like a search engine. It generates responses based on the patterns it learned during training. That's why it's so good at sounding human and why it can help with coding, but it's also why it can sometimes hallucinate or state things confidently that are just plain wrong. It's a tool.
So viewers, this is the session for Maya today. We will meet you another Maya session. तब तक के लिए अल्लाह हाफिज, पाकिस्तान जिंदाबाद.